जय संस्कार वीडियो नंबर 2.10 2.9 टॉपिक છે ઇલેક્ટ્રોસ્ટેટિક્સ of conductor and example number 2.7 these two are cancelled for this particular year तो આ બે વિશે વાત નહીં કરીએ ખરેખર ઇલેક્ટ્રોસ્ટેટિક્સ જે છે એ કંડક્ટર્સ માટે છે બેઝિકલી એવું બતાવે છે કે કોઈ પણ કંડક્ટર છે એની પાસે ફ્રી ચાર્जेस હોય છે so whenever external field is acting on it what is going to happen that free electrons which are present in this conductor are aligned themselves opposite to the direction of external electric field therefore inside a conductor electric field is always zero this is very important result for AIEEE, JEE or NEET examination you should remember this that electric field inside any conductor is zero. There is also an effect which is called electrostatic shielding that is also part of it. You can easily understand it just by reading the given theory that is provided to you. So now let's just discuss about dielectrics and the polarization. So these dielectrics are considered as a non-conducting substance. So non-conducting substance that means it is not having any kind of free electrons. And once anything which do not possess free electron, you can understand that cannot conduct anything. So we are trying to discuss about this dielectric and this dielectric material leads to the property which is called polarization. Let's understand it with a simple example. Suppose there is an electric field E which is acting on this particular rectangular shaped dielectric. First one is conductor and second one is dielectric. So what is happening if external field E0 is applied obviously in this particular direction, in the direction of arrow, you need to understand the arrow of electric field is describing that in this particular direction electric field is decreasing. So electric field is shown to you. Now because conductor do have free electrons, free charge carriers, therefore electron sets in the opposite direction. So in this direction the positive one because electric field is decreasing, so positive over here, negative over here. So the electric field induced inside the conductor is exactly in the opposite direction of the external field, and therefore we can say that electric field inside a conductor is always exactly zero because applied external electric field is always equal to the induced electric field. This is so clear method that you don't need to do it again. Okay. Now let's just move on to the dielectrics. What happens if I put this particular dielectric substance into the external electric field? So then this dielectric material do not have this free charge carriers. Therefore, there won't be any net charge on the sides of this dielectric, but it is somehow able to induce certain electric field inside it. So, by the presence of this external electric field, there is some little induced electric field is developed, which is not equal to induced. That means external electric field is not equal to electric field induced, and therefore there should be certain electric field inside this conductor. Okay, so this conductor now There is a plus delta charge and there is a minus delta charge. So this one has permanent dipole moment. Two charges are separated by finite distance, that is dipole moment. So these two have permanent dipole moment, while hydrogen and oxygen, the center of positive charge and center of negative charge coincide on each other. Therefore, we call this two as a non-polar. There is many more examples of polar and non-polar, but let's just try to understand it this way. For the non-polar molecules, in the absence of electric field, when electric field is zero, the charges are the molecules are separated in this way. In this particular way, there is a no induced polarization can be seen in the absence of electric field. But once electric field is not zero, electric field is applied to this particular molecules, it will try to align themselves. It will try to align themselves in the direction to the external applied field. Now let's just talk about the polar molecule. These particulars have this permanent dipole moment, but this permanent dipole moment is oriented in such a way that there is a net electric field due to this wall are going to be zero in absence of external field. What if there is an external electric field which is applied to it? If external electric field is applied to it, it will try to reduce the effect of external electric field, and by doing so, it will align themselves, the dipole moment or dipole itself align themselves in such a way that is opposite to the direction of given external electric field. So whether we are talking about polar or non-polar, in the presence of external electric field, it shows the effect. Okay, it shows the dipole moment which is arising inside this dielectric. So if we are talking about material which is a dielectric, we are talking about this as a slab or something made up of dielectric material. So in dielectric also, if the induced electric field inside this dielectric is directly proportional to the external electric field, then these kind of dielectrics are called linear isotropic. Isotropic dielectric. Isotropic, that means it is same in all the directions. Okay, so linear isotropic dielectric, because the polarization or permanent dipole moment for unit volume, which is called polarization. So if this is generating and it is proportional Okay, these two are conducting plates. So what is going to happen over here on these particular plate are generally having two dimensions, that is length and breadth. It do not have any width because we are talking about plate. Plate generally do not have the thickness. So over here certain charge will get accumulated. There should be a negative Q charge, and over here there should be certain positive charge. Charge upon area is called, yes, charge upon area is called surface charge density, and surface charge density can be denoted by sigma p. So over here net sigma p charge, and over here negative sigma p charge would be there. So one thing that we should note over here is that there is a surface charge density which is arising over here is due to the bound charges, not the free charges, because dielectric do not have the free charges, and the electric field which is set up in this particular due to this dielectric field. So inside these two or between these two conductors, as I have put it, a dielectric over here, due to the presence of these dielectric, the effect of electric field is going to get reduced from as compared to the case when I have put in nothing between these two. So by doing so, by putting this dielectric, we are reducing the effect of external electric field.